Today we're going to be starting Chapter 8, which is on rational functions. And Section 8.1 is going to be talking about modeling inverse and joint variations. So that's what our goal is. We're going to use these inverse variations and joint variation models. Now, if we remember back, we talked about direct variations. And a direct variation is two variables, x and y, show direct variation provided that y equals a times x, where a is a non-zero constant and the constant of variation. So we had to find what a was, plug it back in, get our equation, like y equals 3x would be an example of a direct variation. Well, when we talk about an inverse variation is two variables x and y that show inverse variation if they're related as follows. And our equation is going to be this. Y equals a divided by s. Okay? They would say that it varies inversely. Okay, so the constant a is the constant of variation, and y is said to vary inversely with x. Okay, so that's how we're going to look at it. So if we solve these equations for y, if we get y by itself, we're easily able to tell whether it's a direct variation, an inverse variation, or if it's neither of those. So in example 1, that's what we're going to do. Okay, so the easiest way to tell whether it's a direct variation, an inverse variation, is to solve it for y. So in example 1 says tell whether x and y show direct variation, inverse variation, or neither. So if we solve this, we get y equals 3x. Well, obviously that is a direct variation. Next, we're going to solve b. So we're going to have x times y equals 3 if we multiply both sides by y. And so now we have y equals 3 over x. Well, that one is an inverse variation. And the last one, y equals negative x plus 5. Obviously, that does not look like either of these two, so this one is neither. Then in example 2, they're going to tell us that to write an inverse variation equation. So it says the variables x and y vary inversely. So we know that it is an inverse variation. So we are going to write this equation, y equals a over x. We know it's an inverse variation. We know that our variables are related in this matter. So what we're going to do is plug these numbers in. We have this and we have this. Well, the easiest way to do this is solve it for a, because we want to know what a is. So if we do that, it's going to be xy equals a. Multiply both sides by x, and so we have xy equals a. Well, that's going to make it super easy to find out what a is, because if we do that, x is 1/3, y is 15, that equals a, so a equals 5. So it says write an equation relating x and y. So what we're going to do is we're going to take our original equation and we're just going to plug a in. So our equation is y equals 5 over x. There is your inverse relation. That's it. So you solve for a, plug it in. Now for the part b of this equation, it says now find y when x equals negative 10. So we just plug it in. So y equals negative 1/2. So when you do these problems, you make sure that you have both those parts that I have squared. You need the equation, y equals 5 over x. That's your inverse variation. And you need the answer after you plug that in. So y equals negative 1/2. All right, example 3 we're going to look at is in your book. It's a table in your book. I'll write it here. All right, so the problem says the number of songs that can be stored on an MP3 player varies inversely with the average size of the song. A certain MP3 player can store 25 100 songs when the average size song is 4 megabytes. So first, it says write a model that gives the number of n of songs that will be fit on an MP3 player as a function of the average song size. So number of songs varies inversely with the song size. All right, so there is our general equation we're going to use. So what we want to do is plug these in. And we want to find what the constant of variation is. So if we do that, we are going to get we're going to use the data that they gave us in the example. It said 2,500 songs. So when there's 2,500 songs, and the song size is 4 megabytes, so then A is going to be approximately 10,000. So N is going to equal 10,000 over S. And then the table that we get is going to be the one above. So if there's 2 songs, plug in 2, we're going to get 5,000. If there's 2.5, we're going to get 4,000. If there's 3, we're going to get 3,333. And if there's 5, there's going to be 2,000. So when they gave us this data, again, here is our inverse variation equation. We plug in the data to get our equation, and then we can plug in any number that we want for the number of songs. For example, if we wanted to extend this and make it 9 songs, okay, the song size is 9 megabytes, whatever, we're going to put in 9, we're going to figure out how many songs we would get if we did that. So when we plug that into the calculator, we're going to get approximately 1,111. It'll be a point in a decimal, so it would go on after that. But that's how I would use that as an inverse variation. So we're going to look at the guided practice questions. So go ahead and pause the video, and you can do those. We're not going to do number 7. Just go ahead and do the first 6, and then hit play when you are ready to resume. And there are the answers for your guided practice. So next we're going to jump down to checking data for inverse variations. So that example is on page 533. And in this one, they're going to give us a table. In example 4, they give us a table and they want us to check, is this in fact a direct variation? So there's the table that they give us, and it says the table compares area in square millimeters of a computer chip with number of chips that can be obtained from a silicone wafer. Write a model that gives C as a function of A. So C as a function of A is going to look like that. So if we want to find the constant A, we're going to have to multiply the area times the number of chips. So if we do that for each of these situations, we'll take 58 times 448. We're going to get 25,984. We're going to take the 62 times the 424. And we're going to get 26,288. We're going to take the 66 times the 392. We get 25,872. And we're going to take 70 times 376. We're going to 26,320. So now notice in here, the constant of variation is are those numbers on the right side. Well, they're not really constant. And in a real life situation, we may have a little variation in what those numbers are. So they tell us to check to see if this is an inverse variation. So we want to find out what the average is here. And if we look at this, first one's almost 26,000. The second one's just over 26,000. Again, third one's almost 26,000. The bottom one's over 26,000. So we're going to say that the constant of variation, then if we do that, is approximately 26,000. So then if we write our constant or our inverse variation, we're going to say that C equals approximately 26,000 over the area. So the number of chips that they give you is going to be this variation equation. The next thing they're going to ask us in this question is to predict the number of chips per wafer when the area of the chip is 81 square millimeters. So now all we have to do is plug 81 in here. And we're going to see that the chip is approximately 321. The last thing we're going to talk about today is something called the joint variation. So we've talked about direct variations, we've talked about inverse variations, and now we're talking about joint variation. So joint variation occurs when a quantity varies directly with the product of two or more other quantities. So a joint variation is like a direct variation, only we're going to multiply by a couple of things rather than just one. So in the equations below, A is a non-zero constant, because once again, A can't be zero because that would make everything zero and we wouldn't have anything. So in this example, it says Z varies jointly with X and Y. In the example below, it says P varies jointly with Q, R, and S. So now when we look at example 5, we're going to do it exactly the same way as we did the inverse variations and the direct variations. We're going to write our equation. It says Z varies jointly with X and Y. So I'll write Z varies jointly with X and Y. Also, we know that Z is 60, X is negative 4, and Y is 5. So we're going to plug in our numbers, 60, negative 4, and 5. And once again, we're going to solve for A. So 60 equals negative 20 over A. So A equals negative 3. Again, once we have the constant of variation, we just rewrite it into our equation. So Z is going to equal negative 3 XY. So there is your equation. And then once again, you need to have a second part. It says find Z when, and then they're going to give you X and Y, or whichever your joint variation variables are. So Z equals negative 3, and they say X is 7 and Y is 2. So that is going to give us negative 21 times 2, which is negative 42. So there is what the answer is for Z. Z is negative 42. All right, next, example 6 says compare different types of variations. We're going to write an equation for the given relation. So we'll have to determine whether it's a direct variation, an inverse variation, a joint variation, and write our equation accordingly. So first one says R varies inversely with S. So this is an inverse variation. Inverse means it's going to be in that form, A divided by S. Okay, so R equals A over S is our answer for that one. Next, it says Z varies jointly. So I know it's going to be jointly, looks like this, Z varies jointly with X. So we're going to multiply these, X and the square root of Y. So there is our joint variation. Third, P varies inversely. So now once again, it's going to be a division with the cube of Q. So Q cubed. D says M varies directly. M varies directly with the square of N and the inverse with P. So M varies directly with the square of N, so N squared, and inversely with P. So we're just going to put those two together. And Z says, again, Z varies jointly, so we're going to multiply those. So jointly with U and V, and then inversely with the square of W. So that's how we write those inverse variations, direct variations, and joint variations. All right, so now what I would like you to do is go ahead and do the guided practice questions on 9 through 14. So go ahead and pause the video and you can hit play when you are ready to resume. And here are the answers to the guided practice questions. Notice on all of these problems, we have to plug in the values we have for x, y, and z to find a. We're always solving for the constant of variation. Then to get our inverse, or our joint variation, what we're doing is we're taking this a and plugging it in. Okay? We're always taking the a and just plugging it into our original equation. And that's how we get our inverse variation. And then they tell us on all of these that we have x equals -2 and y equals 5. So we're plugging those in to find what z will actually be. Then if we jump down to 13 and 14, they're just putting in, again, exactly like it says, if it's an inverse variation, if it's a direct variation, if it's a joint variation. So make sure you know how to write each one of those. So realistically, in this section, we are using joint variations, direct variations, and inverse variations. We're plugging in the numbers that we have for x, y, and z, and then we're finding the constant of variation. Once you find the constant of variation, you plug it back into your original equation, and then you solve it for whatever we need to. So essentially, that is all we're doing in this section, looking at joint variations, inverse variations, and then again a review of the direct variations. So here are your homework sets for section 8.1.